Grade 12s, I am your instructor, Mr. Pimbuisa. We are happy to have you guys again on our online classroom. So today's session is basically starting your grade 12 content. I hope by the time you clicked on the play button for this video, you had already gone through the 4 parts revision videos for our online classroom. It is very, very important for you to have gone through those videos before you look at your grade 12 content, because what you do in grade 12 is dependent on you understanding the basic principles we covered in the last 4 videos. So please make sure that you had already watched all the videos before you play this one, so that you can fully benefit from the grade 12 content we will be discussing. Of course, in some of the parts of the videos or of the lesson, I am gonna make reference to some of the stuff we discussed in the last 4 parts revision videos. So please make sure that you try and connect the dots to see how you actually had already done the stuff in grade 10 and 11. We are just being more specific in how we apply the work that you did in the previous grades. So without wasting any time, let's look at our session outline for today. Now, as you can see, we are doing mid-latitude cyclones, right? So that's the topic of discussion, mid-latitude cyclones. Now you'll notice that we think about where the mid-latitude cyclone will form. So we think about the area of development. We also need to know the conditions necessary for these systems to form, the general characteristics. Remember guys, when we think about general characteristics, we are basically thinking about what features are unique to the system, what features define the system, what features characterize the system or allow for us to classify or identify the system. So what is unique to the system? That's what we think about in general characteristics. And we also need to know now the stages of formation. How do these systems form? Remember we would have already looked at where they form, right? And in that we'll think about what happens in the initial stage, what happens in the developmental stage, which is also known as the wave stage, what happens in the mature stage, and what happens when the system gets destroyed, which is in the occlusion stage. So that's what we need to know and understand. Now we also need to think about how do you identify the system on a synoptic weather map. What weather patterns are associated with the system. Now remember, just to go back a bit, for synoptic weather map identification, you also need to be able to identify the system on a satellite image. So make sure that you watch till that part of the session so that you really know how do the system actually look in real life as seen on our satellite images. So what features do you look for when you analyze the satellite image? So remember, in part 4 of our revision series, we already had in our grade 10 and 11 rather part 4 video, we had already looked at what components make up a satellite image and how do you identify the system on a synoptic weather map and a satellite image as a result. So remember that. Now we also now have to think about weather patterns. Now remember, the weather patterns that we will think about is called front, warm front, and occluded front. So we'll think about the different types of fronts and what conditions are associated with them. Now just to add on this, there is another front we think about what happens in that front, and that is a front we call the polar front. So we'll talk about the polar front when we look at the stages of formation or of development of the system. And then the last part then will want you to look at the impact of the system on humans, the environment, and the economy. Now, of course, remember with impact, we can think about positive impacts and a negative impact. Now, with negative impacts, we'll then have to think about what strategies can we employ to prevent the impact. Yeah, so those are the things we're gonna look at. Those are the things we will try and break down for you. Now, I have to make the sessions more manageable and break down the content for you so that you don't have too much information all at once. So what I've done then to reduce that or to avoid the impact of information or knowledge overload is that I've broken the sessions for mid-latitude cyclones into 3 parts. Now, this will be our first part. Now, this video will be addressing the first part. So they will be looking at the first 5 sections of the topic that you see, and it means the second video will be looking at the last 3 sections of the topic that we'll be looking at. Now, the third video then will be looking at possible examination questions for this section, just to see how can we apply the knowledge that we would have covered in part 1 and part 2 of our videos. Now, that's how all of my videos are going to be arranged. All of my sessions are going to be arranged. Please make sure you watch all 3 sessions so that you fully grasp the topic. Now, it is not a crime for you to watch the video at least 3 times if possible. You can download it and save it on your device and re-watch it offline to save your data. So please make sure you do that. Now remember, this is content that will be relevant for you now in term 1 because it forms part of your term 1 test. It will also be relevant to you in your June exam if you guys are going to be writing a June exam in your school, and it will also be relevant when you write your preliminary exam, and most importantly your final examinations. So make sure that you go through the videos, master the content. Feel free to rewatch the video, take it back where on parts you don't really get, and try to rewatch the stuff. And I will be very, very happy to have you guys comment in the comment section, and I'm gonna respond to your questions with no problems at all. So without then wasting even more time, let's get to the content itself. So as I said, the video is covering the first 5 parts of our lesson or of our topic. So for this first part, now before we even think about where do mid-latitude cyclones form, we need to think about what are they. What are mid-latitude cyclones? I think that is a basic that we need to cover for ourselves. What is a mid-latitude cyclone? Now, before we even look at the short notes I put in on the slide, now let's think about the weights themselves. So the system is known as a mid, and it's also known as it's a mid-latitude, and the last part is cyclone. Now, before we even look at complicated definitions and all, let's just break down the weights apart for our understanding. Now, the system is known as a mid-latitude cyclone. Now, the word mid, that is colored in yellow over there, we can all agree that it stands for middle, right? So the word mid stands for middle. I am using my mouse, guys, to write, so my writing may be skewed, but I'll try my best to make the stuff as visible as possible. Yes, so the word mid over there stands for middle, as I said. Now, and then the next word is latitude. Now, latitude takes you to what you did in grade 4 when you started doing social sciences. So in grade 4, you were taught about lines of latitude and lines of longitude. Now, you were taught that lines of longitude are these lines, right? And you were taught that lines of latitude are these lines. The horizontal lines are lines of latitude and the vertical lines are lines of longitude. Now, in reference to what are we looking at lines of latitude? It is in reference to the Earth, right? So if this is the Earth and this is a line of latitude that separates the Earth into two equal parts, that we call the equator. Now remember, the equator is at 0 degrees. It is not at 0 degrees Celsius. It is at 0 degrees, the angle, right? So please, we're not talking about temperature here, we're talking about the angle. So it is at 0 degrees, the angle, right? Now we know that this line is the equator and it cuts the Earth into two separate hemispheres. And what are those hemispheres? It is the northern hemisphere, and the southern hemisphere. Now, to build upon that, we know that now we even have even more lines of latitude that will separate your southern hemisphere and northern hemisphere again. Now, that is a line that we draw here, and this line is at 30 degrees, right? Remember, 30 degrees the angle, not 30 degrees the temperature. So it's at 30 degrees. Now, the line that is at 30 degrees north, we call that line the Tropic of Cancer, because it's in the northern hemisphere, and the one that is in the southern hemisphere is the Tropic of Capricorn. Okay, now I hope you understand that, we remember that, right? Now, since we are looking at lines of latitude in terms of cyclones, and remember that cyclones are specific kind of weather systems. So now it takes us to what you did. Fast forward from grade 4 to grade 11 to what you did in grade 11. Now you were taught the global air circulation system. So you were taught that now the line at 0 degrees is known as the tropical low pressure, or the equatorial low pressure, or the ITCZ. So that's what you were taught in terms of climate. And you were taught that at 30 degrees you have the subtropical high pressure. Remember that you were taught that we have the subtropical high pressure. High pressure belt, right? And then you were taught that we have another line, and this is at 60 degrees, and we call that line the subpolar low pressure belt. 60 degrees subpolar low pressure belt. Now, the 60-degree low, or rather the subpolar low pressure belt, is followed by the polar high pressure belt. So it's followed by the polar high pressure belt. Yeah, my writing is way better than it should be, but I hope we get the point. So it's followed by the polar high pressure belt. Now you can see that within our lines there is an alternation of the pressures, or of the pressure in each layer. So at the equator, remember we said we have the ITCZ. So here is the ITCZ, and the ITCZ is followed by the subtropical high pressure belt, followed by the subpolar low pressure belt in purple, and at the poles we have the polar high pressure belt. And you see that our pressures are alternating. And why do they alternate? Simply because air moves from high pressure. Remember, here we have the subpolar high pressure belt, So air will move from this subpolar high pressure belt and it will go towards the equator, right? And the equator has the tropical low pressure belt. And again, this air will go to the opposite direction again, so it will flow towards the subpolar low pressure belt, which is a low pressure, right? So again, it's because of our effect of pressure gradient force. Remember, we talked about it, which moves air from high pressure to low pressure. And it means now at the poles, because we have a high pressure, we have our air moving towards that direction, right? So let's stop it there. It's just a bit of revision. Now, how is that connected to the name itself? Now we are looking at mid-latitude cyclones, and we've already identified our lines of latitude in terms of climatology, right? So these are the lines we have. We have the equator, we have the subtropical high pressure, we have the equator, we have the subtropical high pressure, we have the subpolar low pressure, and we have the polar high pressure. Now, if we were just focusing on one hemisphere, we know that what is in the southern hemisphere is also up there in the northern hemisphere. Now, if we were focusing on the southern hemisphere only, now you will agree with me that the equator and the poles will be our outermost belts, right? If we were just focusing on the southern hemisphere. Now, which belts are in the middle? Which belts are in the middle? Which lines of latitude are in the middle? You will agree with me that it is the line 30 degrees and the line 60 degrees. Now, what is that telling us then? It is telling us that this system, being a mid-latitude cyclone, is a system that forms in the middle latitudes. Are we fine? Now, what is a cyclone? We discussed that in the previous video again. In the first section of the previous video, we defined what a cyclone is, and we said that a cyclone is a low pressure system associated with what? Warm, moist, rising air. And we said these systems are characterized by having precipitation or unstable weather conditions associated with them. And what is that telling us then about a mid-latitude cyclone? It is basically telling us that a mid-latitude cyclone is basically a low pressure system that is made up of our warm air, which will be found in the warm front, right? But because it is located between 30 and 60 degrees, where in its surrounding there is a cold there's a cold polar region and a warmer subtropical region, it means the system will have both cold and warm air, right, associated with it. And this cold air will form our cold front, and the warm air will form the warm front. And we say that this system moves from west to east because it is steered or driven by tropical westerlies, or it is driven by westerly winds. So let's just cover a bit of that. Now, as much as we have air moving from high pressure to low pressure, as we discuss in this diagram, we also talk about winds, right? How the winds are, or how the winds will decide to move. You must note that we have easterly winds, two types of winds, right? Easterly winds and westerly winds. So we have two types of winds, easterly winds and westerly winds. Now, you must know that these winds will always alternate within the belts, within the pressure belts. Now, what does that mean? It means that when we have tropical easterlies at the poles, they are going to be followed by what? Yes, you are right, they are going to be followed by your tropical westerlies, because the winds do what? They alternate. Now, because we have westerly winds here between 30 and 60, it means between 0 and 30 we are going to have what? Easterly winds. Are we fine with that? So that's what it means. I hope we are fine with that. Now, because that is the case, that is basically showing us that the system, because remember we said it's a mid-latitude cyclone, which means it forms in the middle latitudes being 30 and 60 degrees. this system then will be influenced by the dominating winds in that belt. And what are those dominating winds? They are basically your tropical westerlies, or you can say your subtropical westerlies. So those tropical westerlies are dominating this region, and we said the system is a cyclone that forms within those regions, and that is basically then telling us that our system is going to form over there and will affect the west coast of countries, because it forms within that belt. But we are not there yet, right? So let's just focus on what that is telling us about the system. So I hope we understand this. I hope we get it. So in essence then, a mid-latitude cyclone is a low pressure system that is made up of a cold front. A cold front is made up of cold air. Where is the cold air coming from? From the polar regions. And it's also made up of a warm front. And where is the warm air coming from? It's coming from the tropical westerly wind belt, right? And we say these two air masses will meet and will form, will lead to cyclonic conditions affecting the interior. Now, since this system is a cyclone, what is that telling us? It is telling us that it has all the characteristics of cyclonic systems, or all the characteristics of low pressure system. Yeah. So as much as they have now the name Mid-Latitude Cyclone, which is self-explanatory really, now they also have alternative names. You can think about it in this way. For example, my name is Peter Mbuisa, right? But I also have an alternative name, and my alternative name is Kabelo. Yeah. So now think about it in that way. If your parents gave you two names, you will be known by either your first name or your middle name. So we call these systems, basically their first name is a mid-latitude cyclone, because it's basically a geographical self-explanatory name. But we also call them, they have these alternative names. They are known as temperate cyclones, simply because of the conditions they bring, right? Yeah, so they bring temperate conditions. They're also known as extratropical cyclones, simply because the conditions they bring, the devastating rainfall and flooding and all of that these systems are associated with, is sort of similar to what you will have in a tropical cyclone, which is the next topic we'll look at after this one. And we also call them moderate cyclones. Now, even though the conditions they bring are similar to what will happen in a tropical cyclone, you must note that the effects are not as dire. They are not as severe as those of a tropical cyclone. That's why we give them the name moderate cyclone. So they bring moderately devastating conditions. And they have some positive impacts as well. So let's remember that fact. Yeah, so those are mid-latitude cyclones. Then let's just look at a part we've already covered, but we just have to formally address. Now, your examination guideline wants you to know where the systems will form, right? Their area of formation. Now, they form in the middle latitudes, or they form in our temperate latitudes. Now, hence they are given the name mid-latitude cyclone. So its description, it's basically a description of where the system will form, right? Now, where do they form? Remember, I had addressed that already. They form in the latitudes 30 to 60 degrees, both north and south. They form 30 to 60 degrees both north and south of the equator. Now, if we look at that in the diagram, this is a global map. Now, if you analyze such diagrams, you need to look at the key, right? Now, the arrows, the black arrows, are showing us where mid-latitude cyclones will be moving, right? And which regions will they be affecting. And the green ones show us where hurricanes or tropical cyclones will be moving and which regions will they affect. Now we notice a lot of things. Maybe let me ask, what do you notice from this? You can pause the video and just think about what you notice about this. Okay, now to continue, you may have noticed that these systems are associated with certain conditions, and they affect certain conditions, and there is a general trend in how they will move across the hemispheres, in the southern hemisphere or in the northern hemisphere. Now if you look at it carefully, I can safely say the first thing I'm noticing is that all the arrows, all the tracks of how this system will be moving, they are all showing that it moves towards the east, right? So it is moving from the western side and it is going to the eastern side. So that's the first generalization I can say I am noticing from that. Now, what is that telling me then? It's telling me that this system forms between 30 degrees and 60 degrees, both north and south. Okay, before we go there, yeah, so now the movement is telling us that the system is being pushed by something, it's driven by something towards that direction, towards the easterly direction. And remember, I had already addressed that with you to say, here we have what? Here at between 60 and 90, we have what? We have easterly winds. We have easterly winds. And here we have westerly winds. And here we have easterly winds, because they alternate, which means the same will happen in the northern hemisphere. In the poles, easterly winds between 30 and 60, westerly winds, and between 30 and 0 or 0 and 30, we'll have our easterly winds. So that is what I'm getting from the system, right? Because the winds alternate. Okay, fine. Now that we've covered that, now that's the trend we notice. They move from 30, they move towards the east, right? Because why? They are in the westerly wind belt. You will often be asked in the exam why they move like that, why they move towards the easterly side, or why they move from west to east. Now remember, guys, I'm saying they move towards the easterly winds. Why? Because they come from the west. And what makes them do that? Because they are driven by westerly winds, or they are in the westerly wind belt. And remember, westerly winds are winds that blow or that come from the west going to the east. Remember, in geography we name winds according to where they come from. I hope we are fine. I hope we are fine with that. We understand that. Now, thinking about it then, even further, remember I had highlighted 30 to 60. So that's another thing I'm noticing to say. They form both 30 and 60 degrees in either hemisphere. And you'll notice then with the greens, which are hurricanes or tropical cyclones, they are basically moving to the opposite direction. They move from east going to the western side because they're in the easterly wind belt. Yeah, but we are going to talk about that in the next topic. For now, let's just focus on mid-latitude cyclones. Now, let's move on. Now, what characteristics define, describe, or generally may describe how this system will form and how it will choose to behave? Now, the first thing that you must know or understand is that they are associated with an extensive low pressure. They are associated with an extensive low pressure where at the center of the system. Why is that the case? Remember, they are low pressure systems, and we know that in a low pressure system, number one, air flows towards the system. Air converges, so it flows towards the center of the system, remember, because they have a closed, or rather they show a closed sense of pressure gradient force, right? So they experience a closed system pressure gradient force. Yeah, so the air flows to the center of the system, so pressure in a low pressure system decreases as you go towards the center. So that's what we mean. And then the next one is that the circulation. We know that all low pressure systems will circulate in a clockwise direction, where in the southern hemisphere, and they will circulate in an anti-clockwise circulatory mannerism in the northern hemisphere. And you can notice that these are things we covered in our golden rules, right? So remember that. That's why we covered the stuff. So now we are just applying with each system. They're also associated with what? They're associated with fronts. Now we have a cold front and a warm front. A front, by definition, let's start there. A front is an imaginary boundary that separates two air masses. And then what is a cold front? A cold front is an imaginary boundary that separates the cold sector from the warm sector. And what is a warm front? Same thing, it is an imaginary boundary that separates the warm sector. Remember, the sectors are named because of their air, or the air they contain, and the cold sector, right? So the warm front will have that. And as I said, from that we can conclude that they have sectors. So they have a cold sector and they also have a warm sector. Now a cold sector is made up of cold air found where? Behind the cold front. Remember, we name fronts according to the air masses that are behind them. So if cold front is called the cold front because it has the cold sector behind it, which has cold air, and the warm sector is named as the warm sector because it has warm air. And the warm front is given that name because the sector behind it contains warm air. Are we fine with that? Which is the warm sector. Now, another characteristic is that if you look at the system in a synoptic weather map, you notice that the system always have an oval isobaric pattern. So the isobaric pattern is always oval. And what is that telling us? It is telling us that the systems are associated with a steep pressure gradient. And what does that mean? It simply means that it goes back to our extensive low pressure story. It simply means that pressure is intense in the system. Are we fine with that? And remember, when isobars are very close to each other, it is also telling us that the system is associated with really strong winds. Really strong winds. So your isobaric patterns will be showing you that. So if they are oval and are slightly closer to each other, they are showing you that. Now what I'm describing is, remember, your isobars will look something like that. Oh, I'm terrible. I'm using a mouse, guys, and a highlighter now to write, which is bad. Yeah. So if you look at these lines, we have lines A and then we have lines B, right? So let me just describe, put the A and the B. Okay, sorry about that. So we have lines A and B. And what are these lines? They are isolines. They are isolines we call isobars. Ne? Are we fine with that? So remember, isobars are lines on a synoptic weather map that show places of equal pressure. We covered that in one of the videos as well. Now, going back to what I'm looking at here. Now, if you look at A and B, if you're thinking about A and B, which one would you say has a steeper pressure gradient between A and B? And why? You can pause the video and try to answer the question for a few seconds. Are we fine with that? Okay, now we can all agree then to say at A, we have a steeper pressure gradient. Why? Because our isobars are closer to each other. Are we fine with that? And at B, we have a less steeper, or we can say we have a gentle pressure gradient force. Now, thinking about the association then of pressure gradient force with the intensity of the winds, you must know that though the steepness of the pressure gradient is directly proportional to the intensity of the winds, which means the steeper the pressure gradient, the stronger the winds we are gonna have. While when we have a gentler pressure gradient force, then the less strong or the weaker the winds we are gonna have. So if you think about then the pressure gradient force, we say that it is very steep in a mid-latitude cyclone, which shows us that they are associated with very, very strong, intense winds. I hope you understand that. Then let's think about the next characteristic. We said that they generally move from west to east. Why? Because they are located in the westerly wind belt. Since they are located in the westerly wind belt, they will be steered by the westerly winds or driven to move from west to east by the westerly winds. I hope you are fine with that, and as a result, they are going to affect the west coast of continents that are where in the middle latitudes, right, between 30 and 60 degrees. In diameter, they are really, really long or wide. Let's use that word. They are really wide. So the extent between 1.5 to 3,000 kilometers. Another characteristic is this traveling speed. They travel at 50 to 60 kilometers per hour, and they last between 4 to 14 days, with the weaker ones lasting 4 days and the stronger ones lasting 14 days, right? Remember, they also get a bit destroyed when they move over the land, or as they go towards the east, they get destroyed. And the most important one is that they form throughout the year, but affect South African west coast in winter. Are we fine with that? Now, that is very important. What is that telling us? The system will occur throughout the year, but it's only going to affect the west coast in winter. So we are interested in the why. Why does that happen? Why does that happen? Now, I am going to try to explain that. I need a lot of space, but it's fine. I need a lot of space to explain it. Now, it goes back to, remember, in one of the videos, I think it was part 3, the part 3 revision video, I explained how the ITCZ works. Remember that? Are we fine with that? Now, we said that the ITCZ moves with seasons, right? Remember, I drew a diagram like this to say, if this was the sun, let me use a highlighter. So if this was the sun, and this was the earth, and we say, remember, the earth is at an angle, the angle is 23.6 degrees, and that was the equator. It means the equator is also tilted a bit, right? Now think about it. We said that the sun will directly hit the mid sections of the earth, right? So which means the sun rays will go directly like that to hit the earth. So they don't directly hit the entire equator, but parts of the equator that are in direct proportion to the sun. Are we fine with that? Now, because remember, we move around the sun and the sun doesn't move around us. So if the southern hemisphere, if the southern hemisphere is receiving more direct sunlight, it means that in the southern hemisphere, in this diagram, it is what? It is summer, right? And now a zone is created because of this direct heat from the sun, and that zone is known as the zone is known as the ITCZ. Are we fine with that? The zone is known as the ITCZ. Very important for you to note. Now, the ITCZ, what does it stand for? It stands for the I stands for inter, the T stands for tropical, the C stands for convergence, and the Z stands for zone. Are we fine with that? So this is what will happen. Now, since it's summer in the southern hemisphere, let's just pause a bit and talk about something else. Are we fine? Now, going back to this other side, remember you were taught about global air systems, right? We said that we have the equatorial low pressure, then we have the subtropical high pressure, and we also said we have the subpolar low pressure, which is at 60 degrees. Okay, fine. Now I want us to focus on the subtropical. I want us to think about the subtropical high pressure. Now remember, your topic number 3 for grade 12 is known as subtopical anticyclones. Now what is that telling you about the cyclones? They are basically those anticyclones. Those anticyclones form where? In the 30-degree line of latitude. And remember, when we did the golden rules, we taught you that cold air and warm air will never ever mix. Remember that. And we said cold air and warm air will, however, meet, right? It will never mix, but it will meet. Now think about it. If we have a layer of warmth in the southern hemisphere, what's going to happen to these high pressure systems that are found at 30 degrees? Now they are going to be pushed further down, or rather further south. They are pushed further south, away from the interior. Are we fine with that? Now, if they are pushed further south, it means now they move from where they from, right? So they move where? From the 30-degree line of latitude, and they go further down. And it means now they are somewhere in between 30 and 60. And we said that between 30 and 60, that is where mid-latitude cyclones will form. So what does that mean? It means now those mid-latitude cyclones will also be pushed further south. They are pushed further downwards, and as a result, these high pressure systems will be blocking the mid-latitude cyclones from affecting the west coast of South Africa. That's why we say, even though the systems are there throughout the year, they do not affect South Africa in other seasons except winter. Why in winter? Because we know that the opposite of what we described there will happen. So what will happen is that you have the earth, sorry about the shape, and you have the tilt now. The earth will be tilted in that way if it is winter in the southern hemisphere, right? And our equator will be facing like that. And if this was Mr. Sun, if it was the sun again, now we know that the sun will directly hit this particular region, right? And it means now the southern hemisphere will be receiving oblique rays from the sun. So if you look at it, the sun is hitting that region directly, and that is where your ITCZ will form again. Are we fine with that? So the ITCZ forms in the northern hemisphere if it is summer in the northern hemisphere. And as a result, what will happen to your high pressure systems then? It means now they can go back to where they belong. They can go back up to the 30-degree line of latitude where they belong, because ITCZ is no longer there. There is less rising air. Are we fine? And because of that, it means now your mid-latitude cyclones can go back where they belong, between 30 and 60 degrees, and as a result, they can affect the west coast. I hope we understand that. To make sure you fully understand this explanation, please maybe reverse the video a bit and re-listen to my explanation on this part. Yeah, so that is what will happen. That's why we say these systems will occur, they will form throughout the year. So it means now in summer, just because they don't affect us, it does not mean they are not there. So in the exam, when they ask you when do this system form, then you will say they form throughout the year. Are we fine with that? And then if a question asks, when do these systems generally affect South Africa, then you are going to say they affect the South African West Coast in winter. And then a follow-up question can be like this: why do these systems, or rather they can say, explain your reasons. What's this? Give a reason for the answer above by accounting. Or rather they can just say account for the reason, or rather give an account for the question above. Remember, you would have answered in that question that the system will be affecting the west coast of South Africa in winter only. So about that. Now, you will then be expected then in that question to clearly detail why, even though the system forms throughout the year, only affects us in winter. So it means now you'll go back to where? You'll go back to our ITCZ story. You'll say that in summer, the southern hemisphere, if it is summer in the southern hemisphere, that hemisphere receives direct sun rays from the sun. Are we fine with that? Now, since it receives direct sun rays from the sun, this means there will be more rising air and in the southern hemisphere, right? And as a result of that, the ITCZ, or the Intertropical Convergence Zone, will be forming there behind the equator. Are we fine with that? Now, since it forms behind, or rather below the equator, it means that it will push all the subtopical anticyclones, all the high pressure cells, being the Kalahari high pressure, South Atlantic high pressure, and South Indian high pressure. It will push all of them further south. And since it will have pushed them further south, it means now they will no longer be at 30 degrees. They are below 30 degrees. And since mid-latitude cyclones form between 30 and 60 degrees, it means now they will also would have been pushed further south, away from their area of origin. And as a result of this, they are not going to affect the South African coast because they are blocked by your high pressure systems. And because cold and warm air, or rather anticyclones and cyclones, cannot mix because they have air, or rather they are formed by air of different temperature, and this air cannot mix, this system will thus not affect the South African west coast in the summer season. While if they ask the question in the positive to say the systems described on the diagram are known to generally form in winter. Explain what conditions allow for them to affect the South African coast in winter. Then you will explain the same thing, but the application, remember, the approach of the question will be different. So in this case, you will say, in the winter season, the ITCZ is above the equator. You can say the ITCZ is in the northern hemisphere. And since it is in the northern hemisphere, it means that these systems, what's this? It means the high pressure systems are also further north, or they are in their area of formation, being the 30-degree line of latitude, or the subtropical high pressure belt. And as a result of this, the mid-latitude cyclones can affect the west coast as a result. You see, the approach is different. It's the same question, same explanation, but how you put it is different. So it's important for you to note how to respond to the questions if they are asked. But the most important thing for this part is for you to understand the content and how it applies. I hope we are fine with that. Okay, let's do a bit of justice again in this section. Remember now we said in South Africa, for this system to affect us, it must be the winter season, right? And why is that the case? Because the system's affecting the system's effect on the west coast is dependent on the migration of the ITCZ and what? And the anticyclones northwards. Because remember, if it is summer in the southern hemisphere, the ITCZ will be below the equator and the anticyclones will be further south away from the interior. So they will be further south away from their area of origin, right? And as a result of that, the system will affect us. So as a result of that, the system will not affect us. So that's what we mean. Now, in summer in the northern hemisphere, the ITCZ migrates. Now, let's just look at what it stands for again. It stands for Intertropical Convergence Zone. Now, convergence. Let's talk a bit about convergence. Remember, which low pressure systems are associated with air convergence? It is low pressure systems. In which season are low pressure systems dominant? In the summer season. Are we fine? Simply because we are receiving more direct sunlight from the sun, and it means more air will be rising, and it means we'll have more condensation and cloud formation occurring and precipitation as a result. So low pressure systems are associated with summer. What is that telling us then about the ITCZ? It is telling us that the ITCZ will always go to the hemisphere in which or the hemisphere that is experiencing summer. Now, since it is summer in the northern hemisphere, our ITCZ will be above the equator. ITCZ above the equator. Remember, when it moves with anticyclones. Now it means the anticyclones will be where? They will be where they belong, in the 30-degree line of latitude. Now, because they are there, it means that the mid-latitude cyclones can freely move, right, between where? Between 30 and 60 degrees. So they will be found somewhere there. Now, as a result of that, mid-latitude cyclones, as a result, will be able to affect us. Yeah, so you'll have your cold front there, and you'll also have the warm front as well, of course. So I'm not saying, guys, the warm front will be in the subpolar region. No. I'm just drawing because it's a small diagram. So what's important is that the mid-latitude cyclone will be closer to the interior and will thus affect the west coast because it will be moving from west to east as driven by westerly winds. So I hope you fully understand that this time. Remember, in the previous example, I used my own diagrams and all of that, so I was just trying to show you in a border diagram how it will actually look. So I hope we are really fine with this section. Now, another general characteristic is that these systems occur in families, right? What does that mean? It simply means that yes, they occur in families. Now, what do we know about a family? What does that mean? Now, we know that a family, let's think about your immediate family, right? It's people that stay in your house, the same house as you. And we know that, for example, this morning, when you are going to school, if you're watching this from school, or you'll think about what will happen on a day-to-day basis. You know that all of you guys will wake up and go to work, your parents will go to work, and you will go to school, right? Now, what is happening is that now you will generally not come back from where you are at the same time, right? Are we fine with that? I hope that is usually the trend in all families. Yeah, so you guys don't usually come at the same time in the evening. So in this case, since you knock off a bit early from school, you'll come back first. Are we fine with that? And since your parents knock off a bit later from work, they will come after. Now, the same example will be applied with mid-latitude cyclones. Now, as much as your family will come back, as much as you and your family will go to the house taking turns or based on when you knock off. A mid-latitude cyclone will also affect or occur as a family, or affect the interior as a family, but now it will be affected by when did it form, or in what stage is it at. Are we fine with that? Now, in this case, we say that the mid-latitude cyclones that are further east, which is the side further east, those are the oldest ones. So we can say they knock off early from school. So they affect the interior first. And the ones that knock off late from work, such as your parents, will be that side of the further west. Are we fine with that? And we say they are the younger ones. Are we fine with that? Yeah, so I hope we understand. Yeah, so them occurring in families simply means then they will occur subsequent to each other in a specific order. So after one mid-latitude cyclone has affected the interior or the west coast, another will follow and another will follow. If you are asked in the exam which one is older, you say the one that occurs first is older because it's going to get to the occlusion stage or get destroyed first. And the one that is further west or far west is the one that is younger because it is yet to affect the west coast. So that's another characteristic of these systems. They occur in families. So I hope you understand that. Now let's think about what conditions are necessary for them to form. So you can think about this section like this. We think about what ingredients are necessary for this system to get cooked up or to form. Are we fine with that? So that's what we think about in conditions necessary for their formation. Now, the first condition we need is distinct air masses. What do we mean by that? We need air of different temperature. That's what we mean. So for the system to form, we need cold polar easterly air masses, and we also need warm tropical westerlies. So going back to our global air circulation animation, so if you look at it here, at the poles you'll have your cold polar easterlies. Are we fine with that? And here between 30 and 60 you'll have your warm tropical westerlies. Now you notice now we are looking at air of different temperatures, and we know that cold and warm air will not mix. They do not mix. But what happens to them? They do meet. Where do they meet? They meet between 30 and 60 degrees. Now specifically in the 60-degree line of latitude, since our warmer air will be here and our cold air from the poles will be there, it means that the two air masses will meet here somewhere there, which is the 60-degree line of latitude. So they will meet there and the 60-degree line of latitude, and we call that part the polar front, right? So they will meet at the polar front. Now when they meet there, there's another condition we need to meet again for this system to form. So now there must be an imbalance in heat energy distribution. Why is that the case? Simply because the air is of different temperature, and that imbalance causes a fight between the two air masses. And what kind of a fight? Guys, not a physical fight. Don't write that in the exam, that the cold air will box the warm air and the warm air will kick the cold air. It doesn't work like that. Remember now, the imbalance is caused by how the system will decide to behave. And how will it behave? Remember, we know that cold air, we said it is more dense, it is more heavy. So it will do what? It will always sink. And we said warm air is less dense, it is less heavy, so it will always rise. So when the two air masses meet, there will be that disturbance, that imbalance, and that imbalance causes friction to form, simply because the cold air will follow the rule and just decide to sink, while the cold air will force its way up. And as a result of that, we have the different stages of development of the system, and a cyclone is born as a result. So I want us to think about this example in the next part. So the next part looks at cyclonogenesis. Now, before I move, remember that what will happen in the southern hemisphere will also happen in the northern hemisphere. What comes to your mind when you think of the word cyclonogenesis? Now we see that the word cyclonogenesis is made up of the word cyclone and the word genesis. Now maybe let's just talk a bit about genesis. What's the first thing that comes to your mind when you think of the word genesis? Now you'll remember the words. I'm sure you think of the words in the beginning. God created heaven and earth, and so on and so forth. So that's the first thing that comes to your mind. So Genesis is the first book of the Bible, of course, and it's famous for those few words, right? Looking at how God formed the earth and the heavens, of course. Now, the same idea applies when we talk about cyclones. Now, here we are basically thinking about how the cyclones are formed. So cyclonogenesis, by formal definition, then refers to how cyclones develop, mature, and how they end up dissipating, or how they end up dying out or getting occluded. Now the diagram here is showing us subsequent cyclones, right? Now we notice that they are connected to each other, and this is a synoptic weather map. Now that is telling us something about the cyclones. Now just to cover a bit of content, now you remember in the lessons we've had, we said that this isobaric pattern being depicted here, this line, the line that is showing 1 1 10, you see that this 1 0 10, you see this line is showing that there is constant pressure across these low pressure systems or cyclone, and we call that line a cycle. So that is a cycle. It's a zone of constant pressure between low pressure systems. It's called a cycle. Now we said that in a cyclone we have oval isobars, and when they are more oval, they are showing us that the system has a steep pressure gradient. We found with that. Remember that's what we covered. Now that's just beside the point. Something I want us to focus on is the cyclones themselves. Now I want you to sort of predict the stages in which each of them is in, because remember, a mid-latitude cyclone is formed by a cold front and a warm front. We found with that. So it's formed by the two full fronts. So if you look at the diagram here, how many mid-latitude cyclones would you say we have? Yes, you are right. We have 3 mid-latitude cyclones over there. And why is that the case? We will have a low pressure forming here, and another one here, and another here, and that is showing us that we have 3 mid-latitude cyclones. Now the next question is, in which stages of formation are each of these mid-latitude cyclones? Now let's start that side in the far west. Now this has just a mini cold front and another warm front, and the pressure is a bit high if we look at it, if you can think about it. Since it is 1010 here, it means here it will be 1005. That's the isobaric interval that we have there. And since the isobaric interval is a bit high, it means that we don't have an extensive low pressure, which means the system is not well developed over there. So the stage of formation it is at is known as the wave stage. It's at the wave stage or the developmental stage. So it's in the second stage of formation. And here our fronts are well developed. We found with that, and we have the lowest pressure at the center of the system. So this is in the mature stage. And here you can notice we have a mixture of a cold front shown by the triangle and a warm front shown by the semicircle. So this is showing us that the occlusion stage is happening there. The system is getting destroyed. So the two fronts have caught up with each other and an occluded front has resulted. So when we look at cyclonogenesis, we're basically thinking about how does the system form? How does it form? How does it move from its initial stage to its wave stage or developmental stage? And how does it move from the developmental stage to the mature stage? And how does it move from the mature stage to the occlusion stage? So that's what we're basically thinking about here. Now let's talk about the initial stage. That's the first stage of formation, right? Now, in the initial stage, this is what happens. Now remember we said the system will form where? It will form between 30 and 60 degrees. So I'm just gonna draw half the earth. Are we fine? And this will be our equator. And this will be our 30-degree line of latitude. Sorry for that, it's skewed. And the last line will be the 60 degrees line of latitude. Okay, so we have these lines of latitude, and we said the system forms in the middle latitudes, which means it forms between 30 and 60 degrees. And we said the air that is found in the 30-degree to 60-degree line of latitude is basically warmer, right? So we have warm tropical westerly air, and here we have a cold polar easterly winds. Yeah. Now we said what will happen is that the cold polar winds, as shown in this diagram, will move to the opposite direction, or rather they will move from the east to the west, and the westerly winds will move from the west to the east. Now where are they gonna meet? So the two air masses will meet where? They will meet here. They will meet here. They will meet at this polar front now, or at the subpolar low pressure. So the subpolar low pressure is separating this this cold air that is found here from the warm air that is found here. So you'll find your cold air here, the cold polar easterly, and the warm westerly up there. Are we fine with that? Now, the 60-degree line of latitude is basically separating the two air masses. Now, since the 60-degree line of latitude is separating the two air masses, what will happen then? We said the two air masses will not mix. They will not mix. But what will happen is that they will meet. Where do they meet? They meet at a front that forms at 60 degrees. Same density. They do not have the same density. So let's always remember that point for us to understand this. They do not have the same density. They don't have the same temperature. They do not also have the same humidity. Now, because of these differences, we know that since the air masses are different in density, it means part of the air is warm and part of the air is cold. And since there are temperature differences and density differences, we know that when something is more dense, it is more heavy. So as a result, our colder air it will be more heavy, right? And it will do what? It will sink. And the warm air is less heavy or less dense, and therefore it will do what? It will rise. Now, due to that difference in density, temperature, and humidity, friction develops between the air masses, which leads to the polar front forming a wave. So the wave kind of a structure forms as a result of this friction and this air deciding that it is going to sink, and the warm air deciding that it's going to rise and fill up the top part. So the wave results because of that. Now, I want us to think about the next stage then. The next stage is the developmental stage. So remember I said a wave forms. Why does it form? It's because of the difference in air masses. Now, if you look at the animation here, it's showing us what will happen in a stationary front. I hope we can see that. Now, remember now, guys, the developmental stage is also known as the wave stage. Why is it known as the wave stage? It's because as a result of the friction that develops when the two air masses move past each other and meet at the polar front, you start now having a wave forming, and at the apex of this wave you start having a low pressure, and we know that now our air will be moving towards the system. Are we fine with that? So now as it moves towards the system, as the air will be moving into the system. Now let's just think about which air we are referring to. We know that the cold air will sink, right? So if this were our wave and this was the polar front, we know that the cold air will be sinking, right? It will be going down because it always sinks, while the warm air will decide that it will be rising because that's how it will behave, right? So at the apex of the system, we have a low pressure developing as a result. So a low pressure develops as a result of this. Let me just draw the diagram properly. So if that was the polar front and this is the wave, so the green represents the cold air and the blue represents the warm air. So it will sink and enter into the system. Now at the bottom of the system, what will form is a low pressure. simply because this cold air will be moving from a region of high pressure to a region of low pressure. So that's why low pressure starts forming where? Where does the low pressure form? It forms at the apex of the system, and as a result you are going to have a low pressure center over there. Now this low pressure, you must take note that this continuously happens. The low pressure thus intensifies over time. Sorry for that. Yes, it intensifies over time. So I want us to just focus on the animation then that is shown over here. Now you'll notice that in the animation, let me just get a laser. So in the animation you have cold and warm air moving past each other, and this is your stationary front or your polar front. Now because they move towards each other, your warm air will rise, and remember, as it rises it cools down and forms the clouds that you see over there as a result. Now you start now having two different sectors that are made up of the cold and the warm air masses, because remember they never mix. So you'll have your cooler air or cold air that side, and you have your warm air that side as a result. Yeah, and as I said, the cold air will sink and the warm air will rise, and as it rises, as you can see, clouds will form slowly over there, and when they become dense, you start having precipitation as a result. So that's what will happen in the developmental stage or wave stage. Now I want us to then think about what will happen afterwards. Now afterwards, remember we had said the low pressure will continuously intensify. So what will happen is that now the system will be propelled to move in the westerly wind belt away from the polar front. Now as it moves, it becomes even more mature, because now it is in a warmer region. Are we fine with that? Now what will then develop as a result is that our cold and warm sectors will distinctly develop, and they are now going to be well developed. Now there were another thing that is well developed is the fronts, because remember the sectors determine which front we're gonna have, which means behind the cold front we are gonna have a cold sector, and behind the cold sector we are gonna have behind the warm front we're gonna have a warm sector, and behind the cold sector we have behind the cold front we're gonna have a cold sector, simply because we give fronts the names according to the air masses behind them or the sectors behind them. Now what will then happen is that the cold air will sink rapidly. Now as it sinks rapidly in the cold sector, or as it enters the system, what will happen is that it will force the warm air to rise rapidly. Now this leads to a steep pressure gradient force forming, which then will mean we will thus have the formation of cumulonimbus clouds along the cold front. So because of this rapid warm rising air, we are going to have the formation of cumulonimbus clouds as a result. So if you look at it, the diagram here shows that we have cold air. In the cold air, we have cold air this side and warm air this side. The cold air occupies the surface and it pushes the warm air to rise rapidly. You saw the words BAM there. They are showing how rapid the process happens. So warm air rises rapidly and it cools down, and you're gonna have the formation of towering cumulonimbus clouds as a result. So these clouds will then bring storms and rainfall and intense conditions that we are gonna talk about in the next session. So in the mature stage, that is what will happen. So the cold front, in the cold air, the cold front will sink rapidly, pushing the warm air in the warm sector to rise rapidly, which will then lead to the rapid rising of air that will rapidly condense and form cumulonimbus clouds, and you are going to have rainfall. Remember, these cumulonimbus clouds will form in front of the cold front. They form in the warm sector in front of the cold front. So let's remember that. So that is what will happen in the mature stage. Now, the system will then get destroyed. Now, there are a couple of things that make the system to be destroyed. Now, one of the stuff that makes the system to be destroyed, which is a stage that we call the occlusion stage, is when the cold air decides to move faster than the warm air. So when the cold air moves faster than the warm air, it means now the cold air will occupy the whole surface, thus increasing the pressure. Because remember, when we have a decrease in temperatures, our pressure will increase. So when the cold air in the cold sector occupies or catches up with the warm air, it will cause all of the warm air to be uplifted upwards, and as a result of that, pressure will increase, so we will no longer have an extensive low pressure, and as a result the system will get destroyed. So as much as, now you must remember, as much as the cold air can catch up with the warm air can also catch up with the cold air. Now, it does now lead to us having two types of occlusion. So we have cold front occlusion. Now, in cold front occlusion, what will happen is that the cold front undercuts the warm front. The cold front undercuts the warm front. And why do we use the words under there? We simply use the words undercut simply because the cold front has cold air, and cold air always sinks. So what will happen is that the cold front will undercut the warm front and occupy the surface. See that it will behave as it would. And now the undercutting will thus cause the warm front to be uplifted from the surface, thus destroying the cyclone. So it will be destroyed. Why does it destroy the cyclone? Because the cyclone is characterized by having low pressure. So at the center of the system. Now, so when we have a high pressure or cold air at the center of, or at the bottom of the system, we are thus going to have what? We are going to have anticyclonic conditions, and this will thus destroy our system. Now, if you look at the animation on the side, you see that cold air is moving faster than the warm air. Now, this cold air, the occluded front forms as a result. So you see that this cold air submerges or lifts up the warm front, and as a result of that, the system will get destroyed. So that's what will happen in the occlusion stage. Now, in the cold front occlusion stage, to be specific. Now, with warm front occlusion, if you look at our diagram here, with warm front occlusion, the opposite will happen. So with warm front occlusion, it only happens when the warm front catches up with the cold front. So if we were to draw a cross section of this, it will look something like that. Remember, this is the warm front, the cold front will be here. So at the surface, we will have the warm front occupying the surface. So this is warm front occlusion. While with cold front occlusion, remember, we have our warm front. We have our warm front occupying the surface, and our cold front, occupying the surface. And you'll have your warm front being lifted from the ground. So the cold front undercuts the warm front and occupies the surface. So with warm front occlusion, what will happen is that the warm front overrides the cold front. So the warm front overrides the cold front, so it will occupy the air. So in this case, why does that happen? It happens simply because the warm front will catch up with the cold front, and the coldest air is found ahead as a result. So you see that the coldest is found ahead as a result, and the system gets destroyed. So the diagram or animation shows what will happen again. So your warm front will catch up with the cold front, and you'll have an occluded front forming as a result. So the system will get destroyed. So that's what will happen in your warm front occlusion. So we'll look at in depth in the next session the conditions associated with a cold front, a warm front, and an occluded front. So now we're just covering how the system will form and move from one stage to another. I hope we understand it. Now, I want us to then think about how we will identify the system on a satellite image. So if this were a satellite image, it is showing us a mid-latitude cyclone, right? So this is a satellite image showing us a mid-latitude cyclone. So it's an animation showing us how it will move. So the first thing that we can identify is that this is circulating in an anti-clockwise direction. Circulating in an anti-clockwise direction. And what is that telling us? It is telling us that this diagram is showing us the mid-latitude cyclone in the northern hemisphere. So let's remember that it's in the northern hemisphere. Now, which front did I say is associated with cumulonimbus clouds forming? Remember I said it is the cold front, right? So in front of the cold front, you'll have these cumulonimbus clouds forming. That's why they are thick and all. And where you have the scattered clouds showed by my yellow there, that is your warm front. Now your warm front has nimbostratus clouds associated with it, and nimbostratus clouds bring showers or little to no rainfall at all. We are going to look at conditions associated with each of the fronts in the next session, as I said. Now this is just an animation of what we're looking at. So I want us to really think about pictures that are not moving. So this is a satellite image again. So the circulation is in an anti-clockwise direction, which is showing us that it's in the northern hemisphere. Now that's one key feature you can use. Now remember that where you see the thick clouds, that is showing us that this is in the northern hemisphere. So that is showing us that is the cold front in the northern hemisphere. Ne? Now remember, they will give you a satellite image that is in black and white color, right? So remember, I told you in the previous session when we were analyzing satellite images that there are different components to a satellite image. Those involve the color, the color, and you being able to associate the color of the features with what is being depicted, right? So if your satellite image was black and white, it's the same picture, but now you look at it in this way. You see the white color is showing you what? It's showing you the band of clouds. Are we fine? And the grayish color is showing you that is land. And the black color there represents parts of the ocean. Remember, you see here there's an ocean, part of the ocean and part of the green land over there, the darker colors. Yeah, so you must always be able to identify those. Now in the southern hemisphere, let's think about another satellite image. In the southern hemisphere, This is what we can see. So this is Cape Town or Western Cape, the coast, and a cold front is approaching that region, and you see your band of clouds over there. So this is how it will look in the southern hemisphere. Now in exams they can give you a satellite image and ask what system is being depicted. Make sure that you are able to identify that. So we have another one over here, southern hemisphere, showing you your mid-latitude cyclone. And if you look at it, the circulation is clockwise, right? Circulation is clockwise. If you look at the band of clouds, it's clockwise. So it's showing you that it's in the southern hemisphere. So you need to be able to identify it. Then let's think about synoptic weather maps. Now, this is a synoptic weather map showing you a mid-latitude cyclone again. Now, if we observe here, our pressure is decreasing towards the center, and they may ask you smaller question to say, what is the isobaric interval here? So you can see that the isobaric interval is 4, right? So you can just simply say 1004 minus 1000 and you get your isobaric interval. So it is 4 hectopascals. Yeah, so that is your mid-latitude cyclone. The cold front is about to affect the interior or the west coast of South Africa over there. And if you think about when is this happening, if you look at this shows you when the chart has been dated. So this is 2013 May 19, 2013 May 19. So that's and then you see it's near winter months. That's why the system will be affecting the west coast, and we know that in the winter months or rather near the winter month, especially May, we have our winter conditions, because already the ITCZ or the sun is shining towards the northern, more towards the northern hemisphere, and the ITCZ would have also shifted a bit to the northern hemisphere. Hence your high pressure systems here are closer to the interior, you see, allowing for the mid-latitude cyclone to affect the interior over there. So I hope we understand. So in a satellite image, this is how, so in a synoptic weather map, this is how it will be represented. So they may put in in the exam or in your test questions, they may put in an A here and a B there and ask you identify front A. You need to say that's the cold front. You see our triangles there. So that's the cold front, and this is the warm front. They may ask you such questions, the isobaric interval, and you see that the pattern is oval in shape. I hope we see that it's oval in shape, so that they may ask you such stuff in your exam questions. And we see that this high pressure is extending towards the interior, and they may ask what isobaric pattern is being depicted there. Remember, that is wedging, or what we call ridging, which is the extension of a high pressure system. So you need to be able to read your synoptic weather map and identify the information given over there. So I hope we are fine with that. I want us to just look at one more for emphasis. Again, you have your cold front, you have your warm front. Your high pressure systems are closer to the interior. So you see ridging is happening again if you look at your isobaric patterns, and you see that this system is further east, which means it has affected the west coast already, and another one is coming behind it, and another one has already passed. And they may ask what phenomenon is being depicted there. They're showing us that the systems occur in families, so that is what is being depicted there. And they may ask you what conditions would you expect when a cold front approaches. So we are going to discuss that in the next session. Now, I want us to then summarize. Let us summarize. So in summary, mid-latitude cyclones are low pressure systems, right? They are low pressure systems, and what's special about them is that they form in the middle latitudes. Now, they occur throughout the year, but they affect South Africa in winter. Why? Because of the migration of the ITCZ and the effect of anticyclones. Now, they form systematically, which means they form in stages due to the changes in the behavior of air as the system forms, right? Now, we have different stages. The first one is the initial stage. What happens in the initial stage? Warm westerly air moves past cold easterly air, where at the polar front. But these two air masses do not mix, but they meet. Remember, they meet. They meet at the polar front. What will happen thereafter is that where they meet, the cold air will do what it does best. It will sink. And the warm air will do what it does best. It will rise. And as a result of cold air sinking towards the center of this system, we have a wave forming as a result. Because remember, this cold air it has a high pressure, so it will move from a region of high pressure to low pressure. So at the apex of that wave that has formed, we are gonna have the formation of a low pressure over there. Now, the low pressure starts intensifying, and that's what happens in the mature state. And when it intensifies, you start having distinct sectors, distinct fronts. You have a warm front being fully developed, you have a wide warm sector being fully developed, and you have your cold front and warm front being fully developed, including the cold sector and warm sector as well. Now, over then you start having different conditions simply because of the difference in air masses. Now, the system will then move from west to east as driven by westerly winds, and it is going to do what? It's going to affect the west coast of the country. Now, after it has moved over the country, its pressure starts increasing, and it gets destroyed when the cold front catches up with the warm front in cold front occlusion, or either when the warm front will catch up with the cold front in warm front occlusion. Fine. Now, the occlusion stage is what happens. So the system will get destroyed because of an increase in pressure, and as a result, it will die out. Now, we said the systems will occur subsequent to each other because they occur in families. Now, you need to then be able to identify them through satellite images. That's what we also covered. So with satellite images, remember the white color represents the clouds. The black color represents the grass and the ocean. The gray color represents parts of the land and clouds as well. Now, some clouds, especially scattered clouds, such as nimbus stratus cloud, and you need to be able to identify those features on a satellite image. Then with synoptic weather maps, you need to think about the isobaric patterns, how pressure is decreasing as you go towards the center of the system, and the different the different conditions then that will be associated with the different fronts. You also need to be able to identify a cold front, a warm front, and an occluded front on a synoptic weather map, and be able to answer questions when asked about that. You also need to be able to look to explain why high pressure systems will be closer to the country when mid-latitude cyclones occur. And that is where you think about the shifting or migration of the ITCZ and anticyclones with the with seasons, right? And you need to fully show that you understand that part. So we are going to look at, however, a continuation, or rather look at the mature and the occlusion stage in more detail in the next lesson. Now, note that coming up we have mid-latitude cyclones, lesson number 2. Lesson number 2, as I said, is designed for you to master what will happen in the mature stage. So it's designed for you to master what will happen in the mature stage and the occlusion stage. So we'll be looking at the associated weather patterns with mid-latitude cyclones, and we'll also think about the impact that these systems have on humans, the environment, and the economy. And lastly, we'll be thinking about how can we mitigate the impact? What are the possible precautionary measures that we can put in place for these systems? I hope we understood everything we did in today's session, and we are more than equipped to explain to someone else how the systems will form, what characteristics characterize them, and what conditions are necessary for them to form and where they form, of course, and their identification on satellite and synoptic weather maps. I hope we enjoyed the lesson today. It was a bit lengthy, but I hope it covers all of what you need to understand and know for the examination, and for your own personal development as a geographer. This is the end of the session. I am Mr. Pimbuisa once again. I am happy to have you in my online classroom. See you in Mid-Latitude Cyclones, lesson number 2. Bye.
Audio Jungle.